Hello and good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to my channel, Gate Conqueror. Welcome you all to the new series, Antennas MCQ series. This series will be useful for all the competitive exams, dear. Wherever antennas concept is there, in those particular series, in those particular exams, this particular series will be useful. So we will be discussing about these multiple choice questions from the concept of antennas. This is part 1. Before we start the class, let me introduce myself. I am GC Reddy. Having overall 15 years of experience in teaching, guiding, mentoring GATE and ESC aspirants. I worked as motivation speaker pan India from the past 12 years, expert in field theory and communications. Before we move in, let me explain you about our Telegram channel. This is the link where you can join us on Telegram. This is the official Telegram channel of the Gate Conqueror group. By joining this Telegram channel, you can access all the Gate Conqueror faculties and get the assistance on a personal level. So take a screenshot of this dear. After the class, you can join us on Telegram, and we'll be with you. We'll be guiding you people. Good morning, Karna. So we are into the new series on antennas MCQ series. So we will be discussing concepts through questions. We'll be discussing concepts through questions. So let us start the MCQ series, everyone. Yeah. First question. For an antenna at R is equal to dash meter, induction fields are equal to radiating fields. For an antenna at R is equal to dash meter, induction fields are equal to radiating fields. Induction fields means field components having factors 1 by r cube, 1 by r square, and higher order like 1 by r to the power of 4, so on. All these are induction fields. Radiating fields are components having 1 by r. At r is equal to dash meter, these induction fields very clearly, if you go for far distance, r is a large value, induction fields will be very, very low. That means at nearer distances to the antenna, induction field will dominate. At far distance, radiating fields will dominate. At far distance, radiating fields will dominate. The near distance, induction fields will dominate. So he's asking at r is dash meter, you'll get this condition where induction fields are equal to radiating fields. At r is equal to dash meter, we'll have induction fields is equal to radiating fields. Yes, try to answer dear. R is equal to lambda by 2. R is equal to lambda by 4. R is equal to lambda by 6. And R is equal to lambda by 8. Try to choose your answer. Try to choose your answer, dear. Just try to choose your answer, everyone. Is the video audio clear? Please confirm the video and audio once. Confirm the video and audio once. Confirm the video and audio once. So, good morning, Bhaskar. How are you, Bhaskar? We started the new series, Bhaskar, on MCQs. MCQs and antennas. Along with our regular series for GATE 2023. Very interesting. Wave propagation is also going hand in hand. You are missing out wave propagation. So what's the answer? For an antenna at R is equal to dash meter, induction fields are equal to radiating fields. What's the answer here? Try to listen carefully, dear. If this is the antenna, largest dimension D, the distance from the antenna, this is R, this value is R, this value is R, at R is equal to lambda by 6, at R is equal to lambda by 6, induction fields will be equal to radiating fields. R less than lambda by 6 means very close to the antenna. Induction fields will dominate. R greater than lambda by 6, radiating fields will dominate. Because remember, induction field means components having 1 by r power 4, r power 3, 1 by r power 3, 1 by r square, so on. So these will have predominant values when r is small value. As r increases, induction fields cannot dominate, but radiating fields will dominate. Got it? So, at near quarters, very close regions, induction fields will dominate. Far away, radiating fields will dominate. At R is equal to lambda by 6, induction field will be equal to radiating field. Option C is your answer. Is that clear? Is that clear, dear? Next question. In a circle we have dash radians. In a circle we have dash radians. Radian is defined as measure of plane angle Radian is defined as plane angle. Radian is defined as plane angle with its vertex. Just a second here. Yeah. Okay. In a circle we have dash radians. Radian is defined as a measure of plane angle. It is defined as a plane angle with its vertex at the center of a circle. With its vertex at the center of the circle of radius are subtended by an arc. Length is equal to r. Subtended by an arc whose length is equal to r. This angle is called as 1 radian. So he is asking, this is called 1 radian. So he is asking, in a circle you have dash radian. In a circle we have dash radian. Okay. So now if you can do this experiment here. You try to draw a circle of radius r and try to take an arc of length r and try to project 1 radian. Continue this and see how many radians can you get in one circle. This is 1 more radian. If you continue the process, you will get 6 complete radians. You will get 6 complete radians. And then a 28% will be left out. That means you have, in a circle, you will be having around 6.28 radian, which is equal to 2 pi. Or in simple words, circumference of a circle of radius r is 2 pi r. Each r is able to subtend 1 radian. Therefore, in a circle, we have 2 pi radian. Each r is able to subtend 1 radian. Therefore, we have 2 pi radian. From this concept, we got the concept called conversion. 2 pi radian will be equal to 360 degrees. From this, you got 2 pi is 360. Pi radian is 180 degrees. Now you are using this, am I right? 1 radian is 180 by pi degrees, which is 57.3 degrees. From all this we got these conversions also. Now, is that clear, Bhaskar? Why 1 by r for radiating fields? Radiating fields are defined as fields in the far field region, far away regions, whereas induction fields are defined as the fields which are close to the antenna. And when we derive the radiation pattern of the antenna, when we derive the electric field and magnetic field components of the antenna, the components, electric field and magnetic field components will have terms called 1 by r, 1 by r square, 1 by r cube and so on. These higher order terms, 1 by r square or more than that, are terms which are actually very close to the antenna, and these fields are called induction fields. Far away fields are called radiating fields. Or the fields that are existing at larger distances. 1 by r square and 1 by r cube cannot exist at larger distances. Therefore, they are called as induction fields. 1 by r can exist at larger distance. Therefore, it is called as radiating field. See, from the basic definition of radiation pattern of an antenna, it is defined that radiation pattern of an antenna is a three-dimensional representation of radiation of antenna measured in the far field region. Am I right? Is it clear? In a circle we have dash radian. So from this concept, there are 6.28 radian or 2 pi radian. Circumference of circle is 2 pi r, or therefore in circle we have 2 pi radian. From this we got the concept 2 pi radian is 360, pi radian is 180, 1 radian is 180 by pi degrees, that is 57.3 degrees. From this you got this conversion. 1 radian is 57.3 degrees. And from this you got the concept that 2 pi radian is 360 degrees. So basically radian is a measure of plane angle. Radian is a measure of plane angle. Is it clear? Radian is a measure of plane angle. This is radian. Can you see this? This is radian. This is a circle of radius r. This is a circle of radius r, which is vertex at the center of the circle, subtended by an arc of length r, will give you 1 radian. Will give you 1 radian. This is more clear. This is more clear. You can see here. This is 1 radian. Circle of radius r with its vertex at the center of the circle, subtended by an arc of length r, will give you 1 radian. I hope from this it is very clear. Am I right? What's this? I'm drawing a circle of radius r. I'm drawing a circle of radius r. Then I took an arc of length same r. That arc is projecting an angle which is called a plane angle, which is 1 radian. And trying to extend that 1, 2, 3. A small part is left out, which is 0.14, 3.14, which is pi radian. Half, one more half, pi more radian. Total 2 pi radian. Total 2 pi radian. Clear? In a sphere, next question. In a sphere, we have dash steradian. Radian is a measure of plane angle. Radian is a measure of plane angle. Steradian is a measure of solid angle. In a sphere, we have dash steradian. Radian is defined as the measure of plane angle with its vertex at the center of a circle of radius r and subtended by an arc of length r gives you 1 radian, whereas steradian is a measure of solid angle with its vertex at the center of a sphere, with its vertex at the center of the sphere of radius r, with its vertex at the center of a sphere of radius r, subtended by an area equal to area of a square of each side r. So what is the area of this square of each side r? R square. So this is an r square area. Each r square will subtend 1 steradian. It's a measure of solid angle. This is sphere. This is sphere. And this area r square is subtending 1 solid angle. This is called steradian. Whereas plane angle is subtended by arc. Radian is subtended by arc. Steradian is subtended by the area. Radian is called as plane angle. Steradian is called as solid angle. If you consider a sphere of radius r, the area of the sphere of radius r is 4 pi r square. Each r square is able to subtend 1 steradian. Therefore, in a sphere, we have 4 pi steradian. In a sphere, we have 4 pi steradian. Is that clear? Yes. Any doubt, please let me know. Is that clear? Yes, please let me know. Is that clear? This is about the solid angle. So in a sphere we have 4 pi steradian. In a circle we have 2 pi radian. In a circle we have 2 pi radian. In a sphere we have 4 pi steradian. In a sphere we have 4 pi steradian. And what is the conversion here? Radian is a measure of plane angle. It is because of arc of length r. Steradian is a measure of solid angle. It is because of the length r square. It is because of the area r square. Therefore, each r will subtend 1 radian. Each r square will subtend 1 steradian. R square is r into r. Steradian is radian into radian. Therefore, steradian is radian square. Steradian is radian square. And we know 2 pi radian is 360 degrees conversion. Pi radian is 180 degrees. 1 radian is 180 by pi degrees. 1 radian is 57.3 degrees. Therefore, 1 steradian is radian into radian, radian square. In terms of degrees, 57.3 degrees into 57.3 degrees. 1 steradian is, please calculate here. Calculate and let me know. Everyone please calculate. I'm also calculating. You also please calculate. It is 3,283.29 degrees into degrees, square degrees. Therefore, 1 steradian is 3,283.29 square degrees. In a sphere, we have 4 pi steradian, converting 4 pi into 3,283.29 square degrees. Converting into square degrees, in a sphere, convert into square degrees. In a sphere, we have 4 pi steradian. In terms of square degrees, 41,252 square degrees. Convert into square degrees, dear. Convert into square degrees and let me know. Multiply and let me know. Multiply and let me know, dear. we'll take the approximation. 1 second. 1 steradian is radian into radian, radian square. 1 radian will take exact value. Let me take exact value and calculate. 2 pi radian is 360 degrees. Pi radian is 180 degrees. 1 radian is 180 by pi degrees. 180 by pi, you are getting 57.2957 degrees. So radian square is 57.2957 degrees into 57.29557 degrees, which will be exact value, which will be 3282.80 square degrees. So 1 steradian is 3282.80 square degrees. (3282.80 square degrees), multiplying this with 4 pi, (3282.80) multiplying with 4 pi, you get 41,252.88. Just I want to keep it more precise, okay? 41,252.88 square degrees, approximated as 1 sphere contains 41,253 square degrees. That's the exact value. Clear? Now that's the exact value. So I repeat it again. Radian is a measure of plane angle. Steradian is a measure of solid angle. In a circle we have 2 pi radian. In a sphere we have 4 pi steradian. Radian is defined as the plane angle with its vertex at the center of a circle of radius r subtended by an arc of length r. Whereas steradian is defined as the solid angle with its vertex at the center of a sphere of radius r subtended by solid area r square, or subtended by an area equal to area of a square of each side r. Therefore in a sphere we have 4 pi steradian. Steradian is a measure of solid angle. Radian is a measure of plane angle. Conversion of radians into degrees, 2 pi radian will be 360 degrees. Pi radian is 180. 1 radian is 180 by pi degrees, which is 57.2957 degrees. 57.2957 degrees. 1 radian is approximate, that which is approximated as 1 radian is 57.3 degrees. It's approximated as 1 radian is 57.3 degrees. Now if it considers steradian r subtends 1 radian, r square subtends 1 steradian. The first 1 steradian is radian into radian or radian square. So alternate unit of steradian is radian square or square degrees. Because radian is given degrees, degrees into degrees will become square degrees. 1 steradian as 3,282.80 square degrees. In a sphere we have 4 pi steradian. Multiplying that, you get in a sphere we have 41,252.88 square degrees, or approximated as 41,253 square degrees. Is it clear? Yeah, just let me know. These diagrams will be helping you out in understanding more clearly. This is the diagram for plane angle dia, as I shown you before also. Plane angle is an angle subtended by an arc R, arc of length R. It's a plane angle with its vertex at the center of a circle of radius R, subtended this is for radian, this is for steradian. You can see here, this is the sphere, this is the sphere, and each R square is subtending one steradian. Each R square is subtending one steradian. This will be more clear. This is one steradian. This is one steradian. That's more clear. Now if you see, if you take a circle of radius R, circumference is 2 pi R. Therefore each R will subtend one radian. In a circle you have 2 pi radian. If you take a sphere of radius R, area is 4 pi R square. Each R square is subtending one steradian. Therefore in a sphere we have 4 pi steradian. So in a circle we have 2 pi radian. In a sphere we have 4 pi steradian. Steradian is radian square, or measured in square degrees. Alternate unit, it is also measured in square degrees. One steradian 3282.80 square degrees, and in sphere we have 4 pi steradian, which is equal to 41,253 square degrees approximately. Is it clear? You can see here, this is a sphere which contains 4 pi steradian. One part you have removed 3 pi steradian, half 2 pi steradian. That part also you removed pi steradian, 0 steradian. That is how you need to understand solid angle concept. Now, steradian is equivalent to, fourth question. Steradian is equivalent to, yes Rohit, steradian is equivalent to radian into radian square. Option A is the answer. FNBW is measured in FNBW is measured in FNBW is measured in, yes, Bhaskar, Rohit. Ready? Anyone? FNBW is measured in No, Rohit. Okay, you tell me one thing, Rohit. FNBW is plane angle or solid angle? Just tell me this thing. FNBW is plane angle or solid angle? FNBW is plane angle or solid angle? Plane angle. If it is plane angle, then how do you measure plane angle, dear? In radian or steradian? How do you measure plane angle? In radian or steradian? How was radian defined? Radian is a measure of plane angle with its vertex at the center of a circle of radius r, subtended by an arc of length r. 1 radian is 57.3 degrees. Am I right? So, FNBW, listen carefully, FNBW stands for beam width between first nulls. Beam width between first nulls. It is a measure of plane angle measured in radians or degrees. What is FNBW? Let me explain so that it will be clear for you. This is the radiation pattern of an antenna. This is the main lobe, indicating the radiation of the antenna. The side lobe, these are side lobes. These are other minor lobes. This is back lobe. Now, the region where there is no radiation, the region where there is no radiation is where you have nulls. This is a null. This is a null. This is a null. this is null, this is null, and this is null. These are all nulls. And specifically, a null that occurs between main lobe and side lobe is called as first null. So this is first null. This is one more first null. Okay. Yes, Rohit, correct. Got it? This is first null and this is one more first null. The angle between these first nulls this is theta. This is one more theta. The angle between first nulls is FNBW. Now you tell me, is it plane angle or solid angle? 100% plane angle. Formula 2 times of theta. FNBW is 2 theta. It's a measure of plane angle. It's an angle through which the complete power is radiated. Now if you take a 3 dB down point, 3 dB down point, at 3 dB down, what would be the power, dear? Can anyone answer? At 3 dB down, what will be the power? This is a 3 dB down point. And if you are scaling the projection, at 3 dB down point, what would be the power? At 3 dB down point, what will be the power? Half. Very good. At 3 dB down point, the power will be half. So if you take this angle, this is again theta, and this is again theta. Again the formula is 2 theta, but this angle through which half of the power is moving is called half power beam width. Half power beam width. Formula again same 2 theta. But the only difference is here, this is null, where there is no power. Condition power P is 0. Here condition power P is 1 by 2, half. And how FNBW and half power beam width are related? FNBW is approximately equal to twice of half power beam width. Remember, both FNBW and half power beam width are measure of plane angle. They are measure of plane angle. They are measure of plane angle. More detailed explanation I'll give in the further coming questions. We'll give more explanation about FNBW and half power beam width. So far, is it clear? So far what I am trying to conclude is FNBW and half power beam width both are plane angles. At FNBW power is 0. At half power beam width the power is half. And FNBW and half power beam width are related as FNBW is approximately equal to twice of half power beam width. Both are measure of plane angle. They are measured in degrees or radians. So FNBW is measured in, FNBW is basically plane angle. Therefore it is measured in degrees and radians. 1 and 3. Option B is the answer. Now, is it clear so far? So far is that clear, dear? So, next question. Half power beam width is measured in. Just now we discussed about this, dear. FNBW is measured in degrees or radians. Half power beam width is measured in. As I told you, both half power beam width and FNBW are measure of plane angle. They both are measure of plane angle. Therefore, half power beam width, just like FNBW, is also measured in degrees and radians. 1 and 3. Option B is the answer. Next, FNBW. FNBW is equivalent to, just now I explained you. FNBW is equivalent to twice of half power beam width. Option B is the answer. Next question. Yes, try to do this, dear. If half power beam width in E plane, half power beam width is a measure of plane angle measured in degrees or radians. Half power beam width in E plane, it is 30 degrees. Half power beam width in H plane is 40 degrees. Beam area is dash 70 degrees, 10 degrees, 4 by 3 square degrees, 1200 square degrees. Yes. Question number 8, try to answer, dear. Question number 8, try to answer. FNBW is 2 times of half power beam width. That's correct. But what is the answer for question number 8? Yes, 1200. How do you get this is, we want beam area. Beam area is a measure of solid angle given in steradian. Steradian equivalent unit is radian square or square degrees. Beam area is measured. Beam area is a measure of solid angle. It is measured in steradian. Steradian equivalent is radian square, or it is also given in square degrees. Beam area formula, omega A is half power beam width in E plane into half power beam width in H plane. Both, this is half power beam width in E plane, this is half power beam width in H plane. As you know, half power beam width are a measure of plane angle. Both are given in degrees, but this beam area is given in steradian, or it is given in radian square, or it is given in square degrees. So as it is in square degrees, you need to multiply these two. Therefore, the formula is in this way. Now, can anyone tell me why we need to multiply? Why can't we add? One thing, we cannot add because plane angle, if you are adding with one more plane angle, you will get one more plane angle. But this omega A is beam area is a solid angle. So thereby you need to multiply. That is one thing. Second, listen carefully here. Second, beam area represents the area through which total power is radiated. Through which total power is radiated. That means power is 1. But half power beam width indicates the plane angle through which half of the power is radiated. This is also plane angle through which half of the power is radiated. This is total power, which will be equal to half power plus half power. When you are writing in terms of power, you add it. But when you are writing in terms of angle, this is a solid angle, you need to multiply. Is that clear? Therefore, 1200 square degrees. Option D is the answer. Any doubt here? See here, dear. The radiation pattern. The radiation pattern. Main lobe. These are side lobes. This is the first null. One more first null. This angle is FNBW, which is 2 times of theta. The power is 0. These are 3 dB. These are 3 dB points, minus 3 dB points. These are minus 3 dB points. And this angle is HPVW, which is again 2 theta. For power is half. So through this cone, half of the power is getting radiated. But this is a plane angle. This is a plane angle like this, dear. Plane angle means like this. Take a sheet. Plane angle means This is plane angle. Take a paper. On this you draw the line. On this you draw this. And the power radiated through this paper. This is a plane angle, which can be drawn on a paper. But solid angle, the radiation pattern is a balloon-like structure. In this balloon-like structure, I am trying to cut this balloon-like structure through this paper like this. You got this plane. But you can also cut this balloon like this. This is E plane for suppose. Then this is H plane. Now here you have one plane angle through which half of the power is radiated. And here also you will have one plane angle through which half of the power is radiated. This half and this half. Plane angle, multiply. You will get that area. Square degrees, radian square, steradian, solid angle area you will get through which complete power is radiated. Because this is plane angle given in degrees, this is plane angle given in degrees, you multiply these both. Here half power is there, here half power is there. Just let me know, is that clear? Is that clear? Okay, good. Yes, Rohit. Are you able to learn new things or not? These are plane angle and omega is the beam area or beam solid angle, which is half power beam width in E plane multiplied with half power beam width in H plane, given in steradian or square degrees. So that's the reason why beam area omega A is theta E into degrees and theta H into degrees. Here it is having half power, here it is having half power, and omega A carries total power. Next, try to do this, dear. An antenna, an antenna has largest dimension of 1 meter, operating wavelength 1 meter, then Fresnel region region is dash meter cube. Try to find out. Try to find out. An antenna has the largest dimension of 1 meter. Lambda is 1 meter. Then the Fresnel region is dash meter cube. Very, very important question here. Very important question. Yes. Let me know what is the answer. Everyone try, everyone try. What is the answer you got? How to find this answer is, it's saying that antenna is having largest dimension D. Antenna is having largest dimension D. Wavelength is 1 meter. Around the antenna, with radius R1, around the antenna with radius R1, this region with radius R1 is called reactive near field region. Here reactive components will dominate. Remember, these are not circles, these are spheres. These are not circles, these are spheres. Okay? One more region around it. With radius R2. With radius R2. This is with radius R2. It's called radiating near field region, or also called as Fresnel region, above which this region is called far field region, are also called as Fraunhofer region. Are also called as Fraunhofer region. Why I am explaining these regions? Because what is asking is an antenna has the largest dimension of 1 meter, D is 1 meter, operating wavelength 1 meter, then find Fresnel region. Is asking us to find the volume of the Fresnel region. Is asking us to find the volume of the Fresnel region. Here R1, the sphere with radius R1 indicates reactive near field region given by 0.62 into under root of d cube by lambda. This region. And with R2, the region with R2 is a radiating near field region or Fresnel region, which is 2d square by lambda. Remember, this is one sphere, and this is one more sphere. So if you want this Fresnel region or radiating near field region, you must remove this volume of the inner sphere. Then you will get this outer volume, this volume. This will be the Fresnel region volume. So how to calculate now? What is the total volume with radius R2? Volume of sphere 4 by 3 pi R2 cube. You will get total volume minus 4 by 3 pi R1 cube. When you get this idea, then this problem is simple. Otherwise, you're done and dusted. Clear? Now I've given you the idea. Just calculate and tell me the answers. Tell me the answer, dear. A. Really? How A, Rohit? How A? Don't think so. Because R2, see here. R2, how much it is? 2d square by lambda, no? Let me calculate here. D is 1 meter, lambda is 1 meter. R2 is 2. Then this volume is 4 by 3 pi into 2 cube. This is 8 into 4, 32 pi by 3 minus R1. D is 1, lambda is 1, 0.62 minus 4 by 3 pi R1, 0.62 whole cube. If you calculate this, this will be 10.666. 32 by 3, 10.666 pi minus this will be 0.3177 pi minus 0.3177 pi. You should remove the volume of the inner sphere, no? Then what do you get? 10.3489 pi. This must be your answer. If you got the logic. You have done it correctly, Rohit, but the problem is, correct. The problem is, you have not removed the inner sphere, okay? No problem. You are from which college, Rohit? SVIT. Next question. Try to find the answer for the next question. Next question. Identify the true statements. Radiation pattern of isotropic antenna. Radiation pattern of isotropic antenna is circle. Radiation pattern of isotropic antenna is sphere. Directivity of isotropic antenna is 1. Directivity of isotropic antenna is 0 dB. Try to identify the true statements from this. Try and identify the true statements from this. Everyone tried here. What is the answer? Identify the true statements. Radiation pattern of isotropic antenna. What is an isotropic antenna, dear? An isotropic antenna is one which can radiate equally in all directions. Which can radiate equally in all directions. Such antenna is called an isotropic antenna. If the antenna is radiating equally in all directions, what is the radiation pattern? It is not circle, but it is sphere. Radiation pattern of an isotropic antenna is sphere. Radiation pattern of an isotropic antenna is a sphere. Which can radiate equally in all directions. If you place an isotropic antenna here, this antenna can radiate equally in all directions. Therefore, the radiation pattern is a sphere. Isotropic antenna is an ideal antenna which can radiate equally in all directions. Therefore, radiation pattern of isotropic antenna is a circle. False. Radiation pattern of isotropic antenna is a sphere. Correct. Directivity. No, if you talk about directivity is the capability of the antenna to radiate in any given direction. Directivity formula 4 pi by omega A. Unitless. It is unitless. Omega A beam area given in steradian. 4 pi is also given in steradian. Therefore, directivity of an isotropic antenna 4 pi by omega A beam area. But you know, radiation pattern of isotropic antenna is sphere. In a sphere, for a sphere, how much is the beam area or beam solid angle? In a sphere, we have 4 pi steradian, or the beam area or beam solid angle of a sphere is 4 pi steradian. Substituting, directivity of isotropic antenna is 1. Directivity also indicates the number of antennas required to cover a sphere. Because now that we got directivity as 1, we can also understand that how many isotropic antennas are required to cover the sphere. How many isotropic antennas are required to cover the sphere? 1. Just one antenna is enough to cover the sphere. That's why the directivity is 1. If you got directivity as 2, suppose for some antenna you got directivity 2. Directivity 2 means, what is beam area? 2 pi, which will cover half. I had shown you in the animation also. 2 pi means half of the sphere it will cover. One antenna will cover half sphere, other antenna will cover half sphere. 2 antennas are required to cover a sphere. When D is 2, when D is 4, beam area is pi. That means 4 antennas are required to cover a sphere. This one antenna, this is one antenna, this is one antenna, and this is one antenna. 4 antennas are required to cover a sphere. Now, what do you understand by this? Directivity. What is directivity telling you? Number of antennas required to cover a sphere. If this number is more antennas are required to cover a sphere. That means each antenna is covering less area, less region. It is concentrating or focusing on a given region. Therefore, directivity can also be defined as the property of antenna to radiate in a given direction, concentrate in a given direction. Is it clear? So, directivity of isotropic antenna, yes, 1. In decibel, directivity in decibel, 10 log of directivity to base 10. Log 1 is 0. You get 0. 0 dB. Isotropic antenna is also called as 0 dB antenna because it exhibits 0 dB directivity. Yes, tell me, is that clear? Any doubts so far? Let me know. Let me know. Let me know. Any doubts so far? Please let me know. Next question. Efficiency of an antenna. Efficiency of an antenna efficiency of an antenna ranges from 0 to 1, ranges from 1 to infinity, is equal to GP by GD, or is equal to GD by GP. Identify the true statements. Yes, everyone try out. Everyone try out. What's the answer, dear? Yes. Fast try, everyone. Everyone joined here. Try out. Efficiency. Efficiency of an antenna is given by eta. Efficiency is defined as radiated power by total input power. Efficiency is defined as radiated power by total input power. WR by total input power is radiated power plus loss power. If you take an antenna, the total input power that is applied, if it is 10 watt, out of this, radiated power is 8 watt, the loss power is 2 watt. So what is the relation? Total input power is equal to radiated power plus loss power. Efficiency is WR by WT, or WR by WR plus WL. WR is radiated power, which is I square RR by I square RR plus I square RL, where RR is the radiation resistance across which the power is radiated. RL is the loss resistance. Try to keep RR as high as possible, try to keep RL as low as possible. Equating. Cancelling out of I square, efficiency is RR by RR plus RL. Cancelling out I square, efficiency is RR by RR plus RL. So efficiency formula in terms of radiation resistance is RR by RR plus RL. Percentage efficiency is RR by RR plus RL into 100. This is in terms of radiation resistance and loss resistance. And this efficiency, if the losses are very, very high, radiation will become zero, efficiency will become zero. If there is no loss, efficiency will become 1. Therefore, efficiency can be between 0 and 1. When losses are very high, radiation will become 0. Thereby efficiency will become 0. When there is no loss, efficiency will become 1. Therefore, the range of efficiency is between 0 and 1. Efficiency of an antenna ranges from 0 to 1. Is it clear? I repeat it. When there is heavy losses, radiation will become zero. Thereby efficiency will become zero. When there is no loss, this RR and RR cancel out. Efficiency will become 1. Therefore, range of efficiency is from 0 to 1. 1 is true. Now, this is efficiency in terms of RR and RL. If you want to write efficiency in terms of gain, it's the ratio of power gain to directive gain. Efficiency is defined as the ratio of power gain to directive gain. Power gain is a case where losses are considered. Directive gain is a case where losses are not considered. For example, if losses are 0, then both are equal. Efficiency is 1. Losses are very high. Power gain will become 0. Efficiency will become 0. In that case also, efficiency is between 0 and 1. So, efficiency is equal to GP by GD, not GD by GP. So, 1 and 3. 1 and 3. Question number 11. Option A is the answer. Is that clear? Next question. On a two-way transmission line, current of two adjacent half cycles are in phase. Current of two adjacent half cycles are in phase. Current of two adjacent half cycles are out of phase by 180. Currents of two adjacent half cycles are out of phase by 180. Current and at any instant of time on two wires are in phase. Current at any instant of time on two wires are out of phase by 180. Try to identify the true statements. Try to identify the true statements, dear. Yes, everyone try. To know this concept, you should know how current is distributed on a parallel wire transmission line. Consider a parallel wire transmission line. The source is positive, is negative. Current will be in this way. From here the positive cycle will start. From here the negative. From here the positive and from here the negative. This is positive. This is negative. This is positive. This is negative. This is negative. This is positive. This is negative. This is positive. Once you draw this diagram, the answer is done. At least now, can you tell the answer now? Very easy now. It is very easy to tell the answer now. Anyone? Now you see what is asking. First statement, current of two adjacent half cycles. Current of two adjacent half cycles are in phase. Current of two adjacent half cycles, are they in phase? No, they are out of phase by 180. They are out of phase by 180. They are not in phase, but they are out of phase by 180. Second statement is correct. Current at any instant of time on two wires are in phase. Current at any instant are in phase. Take at any instant. At any instant of time, how is the current on these two wires? Compare this point and this point. Are they in phase? No. They are out of phase by 180. They are out of phase by 180. Current at any instant of time on two wires are in phase. No. Current at any instant of time on two wires are out of phase by 180. Correct. 2 and 4. 2 and 4. Option D is the answer. Question number 12. Option D is the answer. Is it clear? Okay. Next. Try this. An antenna has an operating wavelength of 10 meter. An antenna of length 5 meter would have the same radiation pattern on that of an antenna with length of dash meter. Read the question carefully and answer here. If this kind of question is appearing, very easily you will solve it once you know the logic. Because right now, as we are practicing now, it will take some time, but once you understand the pattern of the given question, it will be very, very easy for you. Just try and find out what is the answer here. An antenna has operating wavelength of 10 meter. That means lambda is 10 meter. Then an antenna of length 5 meter means lambda by 2 length will have same radiation pattern and that of antenna with the length of dash meter. Lambda is 10 meter. This antenna is of length 5 meters. This antenna is of length 5 meters. This antenna is of length 5 meters. Lambda value is 10 meter. It means lambda by 2. 5 meters. I'm right. Lambda by 2 is 5 meters. This antenna is of 5 meters. Lambda by 2 means how is the current? 1/2 cycle. 1/2 cycle in the given antenna. Now this will have same radiation pattern of that of which antenna? Let us see. If you take 10 meter antenna, 10 meter antenna, L is 10 meter, one half cycle, one more half cycle. This fellow lambda by 2, one more lambda by 2. For every lambda by 2, the current will reverse its phase. Total current 0, no radiation. No radiation, no radiation. So this is wrong. This is wrong. If you take 20 meter, five, one more 5, one more 5, and one more 5. For every 5 meters, it will, for every lambda by 2, it will reverse its phase. Every 5 meters, the current will reverse its phase. Total current 0. No radiation. Take 15 meters. 5, 10 and 15. Every lambda by 2, the current will reverse its phase. You can see here, length is equal to 15 meters, length is 5 meters, are having same radiation. Therefore, option B is the answer. Got the logic, dear? Got the logic? These both are having same amount of current, which is responsible for radiation. Therefore, both will have same radiation. Option B is the answer. Next. Identify the true statements. Identify the true statements. A straight conductor fed with the DC current radiates. A straight conductor fed with the DC current radiates. A straight conductor fed with an AC current radiates. A curved conductor fed with DC current radiates. A curved conductor fed with an AC current radiates. Identify the true statements. Try and find this, dear. Yes. A straight conductor fed with DC current a straight conductor with the fed with the DC current radiates. A straight conductor with AC current radiates. A straight conductor fed with AC current radiates. A curved conductor fed with DC current radiates. A curved conductor with AC current radiates. A curved conductor fed with AC current radiates. Okay. Now you tell me, dear. A straight conductor fed with a DC current radiates. A straight conductor fed with a DC current radiates. A straight conductor fed with AC radiates. Curved conductor fed with DC radiates. Curved conductor fed with AC radiates. Which of these statements are true? Basic question. Basic question about radiation mechanism of antenna. Good morning, Shivina. What you said? Are you preparing for BARC or ISRO? BARC or HAL? For which exam you are preparing, dear? Both. All the best, all the best. Good weightage from antennas. We started MCQ series. Daily we'll solve 20 to 30 questions. Daily we'll solve 20 to 30 questions. Approximately we'll solve 500 questions in antennas and wave propagation. So now, a straight conductor fed with DC current radiates. What is the condition for radiation if an antenna needs to be radiated? Condition for radiation. condition for radiation. L into di by dt is equal to Q into acceleration. L into di by dt is equal to Q into acceleration. This is the condition for radiation. Now if you see the first one, a straight conductor with a DC current, there is no time varying current here. It won't radiate. As it is DC current, neither there is acceleration or deceleration of charges. Both the conditions fail, therefore this fellow will not radiate. A straight conductor fed with AC current radiates. Straight conductor, AC current, time varying current is there, it will radiate. Curved conductor with a DC current radiates. Curved conductor, when apply DC current, due to the curved structure, you will have acceleration and deceleration of charges. Thereby it will radiate. Curved conductor with AC current. Anyways, you are having AC current. Automatically it will radiate. 2, 3, 4. Option B is the answer. This is the reason why in vehicle, in cars, you have antennas with curved structures. Because in car, what we apply is DC. In car, from battery of the car, what you get is DC. Therefore, you will have this curved structure so that you can use this antenna for receiving or radiating the signal. Got it? Any doubts here? Next. In a given radiation pattern of antenna, if half power beam width is 40 degrees, Fn BW is dash degrees. Fn BW and half power beam width, what are those dear? Are they the measure of plane angle or solid angle? Fn BW and half power beam width, are they plane angle or solid angle? Fn BW and half power beam width, are they measured in plane angle or solid angle? Fn BW and half power beam width, how they are measured? They are measured in plane angle. They are measured in plane angle. Why question mark? Shabina? Why question mark? See, this is the radiation pattern. Radiation pattern. Main lobe. Side lobes. Nulls. This is the first null. One more first null. The angle between these first nulls. This is theta. This is again theta. Total angle 2 theta. And this angle between these first nulls gives you this beam area. This is given as Fn BW, beam width between first nulls. It is 2 times of theta. This is null. Power is 0. Here maximum power. Power is 1. Here power is 0. The formula Fn BW is equal to 2 theta. for power is 0. Now if you take 3 dB less point, at 3 dB less, how much will be the power? Shibina? No confusion, no confusion. I'll explain, don't worry. Let us not jump into answers, Shibina. I'll explain the concept again once. Then you tell me the answer, okay? Listen carefully, very, very important concept. Interview question also. Listen carefully. So, at 3 dB down point, the power is half. Here also the power is half. Take the tangent and through this cone, how much power is radiated, Shibina? Half the power. Through this cone, half of the power is radiated. Theta. This angle is half power beam width. Formula 2 theta. Power half. At those point, power is half. And how they are related? FNBW, remember, larger angle is 2 times of half power beam width. Both are measured in plane angle only. Plane angle means they are measured in radians or degrees. They are measured in radians or degrees. Now if you take beam area, you will get more clarity. Now how beam area is measured here? Beam area is the area through which the power is radiated. Beam area is also called as beam solid angle. Beam area is also called as beam solid angle. It is a solid angle measured in steradian. How beam area is related to half power beam width? Beam area is half power beam width in E plane into half power beam width in H plane. Listen carefully. How it is measured here? Steradian. Steradian means radian into radian. Steradian means radian square. Radian, one radian is 57.3 degrees. When you multiply, steradian one more unit is square degrees. Degrees into degrees. Square degrees. Therefore, steradian beam area can be measured in steradian or radian square or square degrees. Beam area is the area through which, or the beam solid angle through which total power is radiated. Half power beam width is a plane angle through which half power is radiated. This is half power radiated. In terms of power, total power is half power plus half power. When you are talking about power, you add. But this is angle, solid angle. This is plane angle. You multiply. Power you add, angles you multiply. How to understand? See here. Radiation means balloon-like structure. In this balloon-like structure, this is E plane. This is E plane. This is H plane. This is H plane. Okay. Now in this balloon, I am trying to insert this. And I am drawing the diagram here. Whatever diagram is there on the board, on the screen, I am drawing here. Now half power beam width, half power radiated in this plane, theta E, measured in degrees. Same diagram I am drawing in this way, here. Magnetic field, half power. This half power beam width into this half power beam width, degrees into degrees. Square degrees, steradian, solid angle, through which the total power is radiated. You will get beam area, plane angle into plane angle, solid angle. That is the solid angle through which the total power is radiated. So when you are considering the total power, you consider half power here and half power here. You may ask, sir, why? Always the pattern need not be symmetric. This plane and this plane need not be same. It can be a bulged structure like this and a thin structure like this. Therefore, half power here and half power here need to be considered. Is that clear? So dear, what's the answer? In a given radiation pattern of antenna, if half power beam width is 40 FN BW, how much? 20 Shabina? Shabina, is it 20? Basically, the answer is 80, but beyond that simple answer, there is a lot of concept also you need to understand. So answer will be 80, yes. See, when you read the question, if this concept will be there in your brain, then it is very easy. This concept is really very, very special concept. Mostly, I can say 99% of the people don't know about this. Just they by heart this formula. They mug up this formula, that's it. If you ask concept, very less, 1%, less than 1% will tell you this concept. A null that occurs between main lobe and side lobe is called as, just now I told you, a null that occurs between main lobe, this main lobe, these are side lobes, and a null that occurs between this main lobe and this side lobe is called as. Nulls are nothing but these regions where there is gaps or where there is no radiation. These are all nulls. If you take more minor lobes, you will have more nulls. All these are nulls. But a null that is occurring between the main lobe and the side lobe is called as first null. First null, option C is the answer. I am happy that at least now it is clear. Yes, ready. C, very good. Next question. In normalized power pattern, at Fn BW, the value of Pn of theta is. Try to draw a normalized power pattern. Normalized power pattern means the maximum value of power Pn of theta is 1. These are the nulls. First null, one more first null, some more nulls, In normalized power pattern, at Fn BW, the value of Pn of theta is, Fn BW is this, beamwidth between first nulls. Formula Fn BW is 2 times of theta. In this calculation, how much is Pn of theta value? Karna. Yes, of course. You also have a suffix, no? Ready. Okay. So what's the value? Shemina, correct. In the calculation of FNBW, here the normalized power 0, 0, 0. Question number 17, option A is the answer. In normalized power pattern, at half power beamwidth, Pn of theta is, at half power beamwidth, Pn of theta is, in normalized power pattern, this is, at half power beamwidth, at half power beamwidth, this is theta, at half power beamwidth, how much is Pn of theta? 1 by 2, 1 by 2, 1 by 2, correct. 1 by 2, correct. 1 by 2, correct. In normalized field pattern, let me draw normalized field pattern. Normalized field pattern. Main lobe, normalized field pattern, main lobe, side lobes, minor lobes, back lobe, first null, one more first null, normalized field pattern, En of theta 1, En of theta 1, this is theta, Fn BW, beamwidth between first nulls, 2 theta, your En of theta is 1. How much is En of theta here? Zero. Option A is the answer. Option A is the answer. Yes. Very good, Shibina. Option A is the answer. Next question. In normalized field pattern, at half power beamwidth, the value of En of theta is, in normalized field pattern, this is normalized field pattern, at half power beamwidth, the value of En of theta is, half power beam width. This is theta, this is theta. Half power beam width, formula 2 theta. At this point, En of theta is En of theta is 1 by root 2. 1 by root 2. Because here, at this point, power is 1 by 2, half. Pn of theta is proportional to En square of theta. 1 by 2. Or you can say Pn of theta power is En square of theta. This fellow is 1 by 2. En of theta whole square. En of theta must be 1 by root 2, 0.707. Very good, Shibina. Perfect. Perfect, 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 perfect. Nice. If power in main lobe is 100 watt, side lobe ratio is minus 20 dB. Side lobe power is dash watt. Take a screenshot here. We'll discuss tomorrow. We'll continue from tomorrow. Or we'll continue, next class. Next class most probably today 9 p.m. Some more questions. Daily we'll add some more questions, some more concepts, okay? Any doubts? Unacademy has two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll have all these features. Along with that, you'll have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions, and customized study planner. If you're going for Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI, where total cost will be divided by number of months without any extra cost. That's why it is very much student friendly, and moreover you can use our team code KNR10, which gives you extra 10% off. The speciality of this team code is not only that it gives you extra 10% off, but also the complete team support. It is not any individual code, it is a team code. The complete team of Unacademy will support you, including the legendary KN Rao sir. In Iconic subscription, you'll get 1:1 live mentoring, increases your chance of getting a top rank. And this is for GATE and ESC combat here. This combat is nothing but a live quiz competition where 20 questions will be given, 60 minutes will be given to you. And this is tomorrow 11 a.m. Tomorrow 11 a.m. you have this combat. Separate paper will be given for mechanical, civil, electrical, EC and CSIT. If you are talented, if you have knowledge, then attempt this combat. And the good thing is there is no enrollment fees for this. You can just use our team code KNR10 and enroll yourself, and all the participants will get guaranteed 20% scholarship, and if you do well, we are ready to give away 100% scholarship also. Free subscription. And one more good thing is not only 20% guaranteed scholarship, 500 lucky participants will get all these gifts here. So immediately after the class, register yourself, enroll yourself by using our team code KNR10. And if you are having any doubt in your preparation journey, subscription or latest offers, then get in touch with our counselor. For the same, you can contact this number. Unacademy, we have introduced a feature called Ask a Doubt feature, where you can ask unlimited number of doubts. You can ask 3 doubts at a time and you can get the solution in your preferred language, and it is very, very easy to ask your doubt also. Just click, crop and submit. So we are here to clear your doubts also, dear. Feel free to ask your doubts on the app. We have the super combo offer going on. With every 2-year subscription, we are giving away 1-year subscription free for campus placement and IT jobs. With every 1-year subscription, we are giving away 6 months subscription for campus placement and IT jobs. The rank predictor is on, dear. The procedure is very simple. Just log in, go to Gate landing page and click on the rank predictor banner. Select your stream, session appeared and paste your URL. Your rank will be displayed. Special class features which includes interactive live classes, polls for the learners, raise the hand option. You never miss a class once the notification is on. You can download the lecture notes then and there. Once the class is done, you can access anytime and anywhere. We are introducing community dear, through which you never miss any updates from your favorite educator. And once the session is done, you can download the notes and practice material. And also, you can share the feedback directly with your favorite educator via polls. And these are the new batches, dear. As you know, every week we start around 8 to 9 new batches. These are the batches which are started on 16th of February. Resilience Gate 2023 for Electrical Explained Bilingual. Resilience Gate 2023 for ECE Explained Bilingual. Ascent Gate 2024 for ECE Explained Bilingual. Ascent Gate 2024 for Electrical Explained Bilingual. Evolve Gate 2023 for Electrical Explained Bilingual. Evolve Gate 2023 for ECE Explained Bilingual. These are the new batches. For all these batches, dear, you can use our team code KNR10. You'll not only get 10% off, but remember, you'll get the complete team support. This is a unique feature with this code, only available on this code KNR10. Thank you all, dear. Have a good day.